Hello, so I'm going to talk to you today about analytical methods and sampling programs for food allergens. When we think about sampling and testing and how it fits into the overall allergen control, it is just a piece of the jigsaw. You cannot just do some sampling and analysis to understand whether you have allergens fully under control. As you'll have heard already, if you haven't got GMP working effectively, or you haven't got good supply chain risk assessment in place or good training, then as I say, you cannot just do some testing in order to work out whether everything is working effectively. So when we think about why you might need to test, well, clearly if you're making a positive free from claim, then almost certainly testing is going to form a part of that. Or if you're looking at maybe precautionary cross-contact label statements. You may be, in terms of your supply chain, you may be trying to validate or monitor suppliers to understand if they think they have a risk of allergen coming in unintentionally, whether they really have. In terms of prerequisite programs and CCPs, you're almost certainly going to use sampling and testing to demonstrate that cleaning is effective. We're going to talk a bit about indicative level testing later on, but that's certainly a place where sampling and analysis is going to form a part. Hopefully you're not doing it for the final reason, which is a consumer complaint or an incident. But if there is an incident, then sampling and analysis can often form a part of understanding what may have gone wrong or how serious it might be. So when we think about how we take samples and how many we take, everything has to be based on risk. Because the samples that you take, it is really critical. The results will only be as good as the right number of samples and where you've taken them from can be. So your sampling plan should be linked to the risk analysis, because the whole point of this is that you are trying to maximize the probability of detecting the contaminant if it is present. So you have to really think about how is the contaminant going to be distributed. And once you understand a bit more about that, that's going to help you decide on how many samples to take and where you take them from. So just as an example, if your contaminant is a liquid and it is distributed within another liquid, then the contamination is likely to be very evenly distributed, and you can take a small sample and be confident that you're going to detect it if it's present. If, however, it's fragments of something in a biscuit, then it won't be evenly distributed and you're likely to have to take a much bigger sample. So think about the type of production environment and the physical nature of the contaminant. So let's just show here an example. Imagine in the top left picture we're looking at baking bread rolls. If your contaminant were milk in the bread mix, in other words, part of the dough that will have been evenly distributed and baked throughout the whole batch, you could potentially only take one sample of bread roll, and if milk were present, you would be able to detect it. But if your contaminant maybe were hazelnut fragments coming, let's say, for example, from the oven from a previous run, then the contaminant will not be evenly distributed and you might have to take a whole tray of samples. In the bottom right hand picture, if you're looking at this, you'll see here that some sesame seeds have been left in this tray from a previous run. And you can easily see here that some of the wells have no sesame seeds at all and some have quite a lot. So again, taking a whole tray's worth of samples might give you a better indicator as to actually what the contaminant risk might be. When we're thinking about cleaning validation and how you're going to take samples for that, then clearly sampling and testing is going to be important. And this is going to happen when you change over between products that contain an allergen and then the next product does not contain the same allergen or maybe contains no allergens. And where you've identified in the risk assessment that cleaning is the control, then you are certainly going to have to be doing some sampling to demonstrate how effective the cleaning is. Sanitation manage this process, but they will get input both from food safety and quality. The sanitation will help advise you on how many samples to take, what type of samples, and which methods you should be using for testing. So cleaning validation is a two-step approach. The first step is the physical validation. So after you've done a cleaning, you're going to have a full breakdown of all the equipment, and then you're going to do a visual check to check that you've got no product left on the food contact surfaces. And then the second step is the analytical testing part, analytical validation. And you're going to be using a protein allergen testing kit based on a technique called ELISA, which we'll talk about a little bit later on. When you're thinking about designing a cleaning validation program, the first step is understanding where allergens are, because unless you know exactly where they are and which raw materials and which stages of production, then you cannot do a risk assessment to understand how allergens may become there where you don't want them to be. You're then going to select samples based on a worst case scenario basis, so hardest to clean areas, difficult to reach. And you're then going to select an appropriate target allergen, which we'll talk about, but you do not need to test every single allergen through a cleaning validation. You can pick a target to say, if I can demonstrate that I've removed the target based on worst case scenario, then all the allergens will also have been removed. You're then going to conduct the validation as we just explained. So the first is the visual inspection, and then the second is this analytical testing. And then if you're going to use any kind of method for verification, a rapid type of test, then this is when you would do the validation of them at this stage. So selecting samples based on a worst case scenario. Always target the difficult to clean surfaces and areas. So if you have rough or pitted surfaces, for example like worn conveyor belts, that's where you want to take samples from, because if you can show that the difficult to clean areas have been cleaned effectively, then the very smooth and easy to clean areas will also have been cleaned. So look out for welds or bends or anywhere really where product could hang up. And it's quite useful to actually watch what equipment looks like when a run has finished while it is still dirty, and also watch it while it's being cleaned. You need to take particular care on areas like filling heads or pumps or filters. But you do want to select areas and surfaces that have a direct physical contact with the product, so the food contact surfaces. And if it's relevant, if you have a piece of kit that has different types of material used in the construction, then it is a good idea to take samples from the different surfaces, because most likely they will clean in a different way. When we think about what to sample, it is important that we test a positive control sample. So this is a sample, a matrix that does contain the allergen before you're going to do the cleaning. The reason we need to test a positive control sample is to check that the method of choice is good enough at detecting the allergen at a high enough level. Once you've done the cleaning, you're then going to take almost certainly some direct surface swabbing samples. Now, you want to take as few number of samples as possible that can answer the question, are the surfaces cleaned effectively? Remembering that you want to take them from different surface types and always the hardest to reach and hardest to clean areas. It's important that you use the right kind of swabs, so these will be allergen specific swabs, the right kind of swabbing buffer or wetting solution, and certainly using the right kind of technique. It may be that you have a CIP system where you'll take a final rinse water, and it's important that you cover all the relevant CIP loops. If your method of cleaning is through purging or flushing, then you're probably going to take samples of material, maybe at timed intervals or weighed intervals. And then it is critical that the next product that you make that does not contain the allergen that was in the positive control sample, that you take a sample of these next made products as well. There will have to be some validation done by the laboratory here through a process called spike recovery that we'll also talk about later, to ensure that if there was any of the allergen carried over into the next product, that the testing would be able to detect it effectively. So when we think about selecting a target allergen, This is where you can choose a target allergen if you've got multiple allergens are used on site. So you pick a target to say, if I can demonstrate that that one has been cleaned, then you know that the other ones will also have been cleaned. So ideally, target allergen will be selected from a product that contains it that will be difficult to clean. So think about sample types that are high in fat, particularly sticky. You want the allergen to be present at a high level in the product to start with, and particularly have a high level of protein. And really importantly, you want to have a quantitative ELISA test available for that specific allergen. And we know that that sometimes can be a bit challenging. So there are lots of things to think about when selecting a target allergen. When we think about the analytical techniques that you might use, almost certainly you'll use the Mondelez method of choice, which is ELISA, enzyme-linked immunosorbent assay. Occasionally, if there is no ELISA test available and you cannot choose a different target allergen, then you might use a DNA technique based on a method called polymerase chain reaction, or PCR. Sulfites, the way to detect them is through a distillation technique, and if you're looking for the presence of something, for example, like lactose, the sugar that's present in milk, you're going to most likely be using a chromatographic method. Those are all test methods that a laboratory will be doing on your behalf. If, however, you're going to use some factory spot check tests, there are several to choose from. So one of them is a rapid lateral flow device, which for allergens will be allergen by allergen specific. There are also some total protein tests, so not specific to either allergen or any other proteins, but they detect total protein. And then there's also the technique of ATP, which is based on bioluminescence, looking for hygiene effectiveness on biomass. When we look at the difference between ELISA and PCR, so the method looking for protein versus the method looking for DNA, the advantages of one are often the disadvantages of the other. So if we look at the advantages, first of all, of ELISA, it's going to detect the protein, in other words, the allergenic molecule, which is clearly an advantage. It is a relatively fast method, which makes it relatively cheap to undertake and fairly low cost. And one of the very big advantages of ELISA, it is a quantitative method, so it will give you a number within a standard range for the test. However, there are some disadvantages of ELISA. They're biological assays. They're based on an antibody-antigen interaction, and they are therefore prone to matrix interference, and they can be impacted by processing. So this is something that we have to be very aware of. There are lots and lots of different commercial ELISA testing kits on the market, and unfortunately they're not all looking for the same target. They'll have different sensitivities, so it is quite hard sometimes to compare results from two different testing kits. We also don't have enough kits on the market for all the allergens that we might need to test for, so that's a clear disadvantage. When we look at the technique of PCR, because these tests can be developed without the use of raising antibodies in animals, then they can be developed quite a lot faster than ELISA testing kits. One other good advantage of PCR is you can extract the DNA from a sample and then look for multiple DNA targets within that one sample. So, for example, you can look for multiple tree nuts from one extracted sample, which can make that part of it a little bit cheaper. DNA can often survive higher levels of processing, which can be an advantage, but can also sometimes be a disadvantage because a positive result confirms the presence of DNA, but not allergenic protein, and that is something to be very aware of. PCR tests are also qualitative. They'll give you a yes or a no answer at a limit of detection. And PCR testing can take a long time, so it is always more expensive than ELISA testing. So I mentioned earlier that the laboratory needs to look out for matrix effects within the sample. And this is something we'd expect an external laboratory to do. So let's imagine that we are looking for the presence of milk protein in dark chocolate. The way the laboratory typically will look for matrix effects is they will take a sample of the dark chocolate that does not contain milk. They will artificially add in a known amount of milk, take it through the whole testing procedure and measure what they get out. Now you'd think that would be fairly straightforward, and if you put in 20 parts per million of milk, that's what you'd get out. However, sometimes you can put in 20 parts per million and actually only recover 2 parts per million. So that's the equivalent of a false negative result. And that can happen sometimes when, in this case here, there's something in the chocolate that is binding the milk and hiding it from the test. So you get a false negative result. Sometimes, however, you can add in 20 parts per million and recover 200 parts per million. And this can be sometimes when there's something present in the sample that to the test it looks like milk, so can give rise to a false positive result. It is why it is really critical that this spike recovery testing is done on all sample types that have never been tested before. And it is also something that is impossible to predict whether a matrix effect is going to cause a problem. So really important that when you're commissioning testing to a laboratory, you ask the question, have they validated the sample I'm about to send in for the allergen I want to be tested using the testing kit that they're going to use? Really important question to ask. Once it's been done once, it doesn't have to be done again. So the next time you are going to send in dark chocolate for the presence of milk to the same laboratory using the same testing kit, they don't have to perform the spike recovery test again, as long as they record that they've already done it. When we think about some of the non-specific tests that I mentioned earlier, there are some total protein tests, and these will detect the presence of total protein. They're only used on surfaces, so cleaned surfaces. They're not specific, as I said, for allergens. So to be honest with you, they have a limited use in this kind of setting. One of the other non-specific tests that we talked about was ATP bioluminescence. So ATP is something that is present in all living organisms, and the test is actually detecting biomass. So it's absolutely critical in hygiene monitoring. It's a very rapid test. It's easy to use. They're used very widely in manufacturing scenarios, but they have a very poor correlation with allergen detection. So they are not advised to be used for that question that you're trying to answer. All rapid tests must be validated first, and we're going to talk about that just shortly. So let's spend a bit of time understanding how an ELISA test actually works, what it looks like. So this is a quantitative ELISA test, and this will be an essential part of cleaning validation type studies. It's usually an external laboratory that will be undertaking this testing, and in the picture on the slide here you've got two examples of different testing kits. So our Biopharm on the top left and Neogen on the bottom right. So each test kit comes with a set of standards that contain either no allergen or some of the allergen that you're specifically looking for. So the standard range goes up to a top standard which has the highest level of allergen for this testing kit, and this will be the top range of the test. So the range is usually from the second standard, which contains the limit of quantification for the test, and the top standard. The testing kit also comes with a series of extraction buffers which are designed to extract the protein from the foodstuff that's being tested. There are then various chemicals that will actually make the test work. And the way it works is that the standards will be used to create a colour change, and usually the darker the colour, the more the allergen. And from the range of the standards, a standard curve will be created, and you'll be able to measure unknown samples against the standard curve, and this is what will give you a quantitative result. So the results that you'll get from a quantitative ELISA will either be reported as It's not been detected at the limit of quantification, so less than the limit of quantification. Or you might get a number where an amount of allergen has been detected between the limit of quantification and the top standard for the test. Or the other scenario is there is more allergen detected than is present in the top standard. So you'll get a greater than the top standard result. Those are the three typical scenarios that you get from a quantitative ELISA test. Let's look now at a qualitative ELISA test. These are not that commonly used, but I want to explain a little bit about how they work in case you are faced with them or you're trying to interpret results from them. So these types of tests, you're looking at one here sold by Neogen. They're also based on ELISA, but they are much, much more simple than the quantitative ELISA that we looked at in the previous slide. And they're simple because you only get one positive control. They're still based on an antibody-antigen interaction, but as you can see in the two pictures at the bottom, you'll have this one positive control sample, and when you're testing your unknown against that control, you are just looking visually to see, are they darker or lighter than the control sample. So in the picture on the left, you've got a blue sample for the colour, and you have a pale pink for the actual sample, which is lighter in colour, and therefore that result is negative when compared to the control. And the picture on the right-hand sample is darker than the control, and therefore there is more allergen present than the standard control, positive control that came with the testing kit. So you get a yes or no answer comparing to the positive control. When we look at the qualitative rapid lateral flow devices, these are absolutely optional if you wish to use them. So they come typically in two formats. They either come in the top left, which is in the form of a strip, or the bottom right, they come in a kind of a handheld device. These are also based on an antibody-antigen interaction, but these are very simple to use, very quick to use, and they are designed for using in a factory QC setting. When we look at the results of these, what you're really looking for is a control line that will tell you that the test has worked okay, and sometimes you're looking then for an overload line to say, oh, too much sample has gone in, I need to do it again. And then you're looking either for a positive line or no line. So it's all about looking for lines, which means it's important to check when you're doing this that you're doing it in a place where you've got good light to be able to see them, because they can be quite faint. They are also temperature dependent, so typically they need to be performed at room temperature, so 20 to 25 degrees centigrade, so you can't often do them in the setting directly next to the line. These on average take about 2 or 3 minutes to perform, and when you compare them to a quantitative ELISA test that will take a laboratory somewhere between 3 and 6 hours to undertake, in that 3 to 6 hours, at least 50% of that time is actually taken up with trying to extract the protein from the sample type. So you can clearly see that these qualitative simple tests that are used on site cannot possibly replicate what's happening with a quantitative ELISA test in a laboratory, which is why they are absolutely not comparable one to another. When we're thinking about when to use what type of sample, when we're thinking about a cleaning validation sample types, it is absolutely essential you will be taking some surface swab samples that you will be sending off to a laboratory for quantitative ELISA testing. If you're also testing for rinse waters in a CIP or purge samples, they will also be analysed using a quantitative ELISA test. When you're testing the next made finished product that does not contain the target allergen, you will also be using a quantitative ELISA test. So it is optional if you wish, in addition to use the qualitative rapid lateral flow devices or a qualitative ELISA test or a total protein test, it is optional to do so. If you are going to use them though, they can only be used on either surface swabs or rinse waters. They cannot be used on either finished products, purge samples or raw materials. For exactly the explanation I gave earlier, they are just not sophisticated enough to extract protein effectively out of those types of samples. When we're thinking about cleaning verification, it is sufficient to use a validated rapid lateral flow device on one run for contact surfaces or rinse waters only. So I mentioned earlier that all rapid tests must be checked first to check that they are effective at what you're trying to do. And the reason it's important that this is done is all of these testing methods are biological testing methods, and they are prone to both false positive and false negative results. Therefore, all of them must be validated before use. Clearly, it is up to the laboratory to do the validation with the quantitative ELISA tests, but if a site is going to use some of these qualitative, quicker checks, they must do the validation, or at least commission the validation. And it's because decisions based on unvalidated tests could be wrong and could also be misleading. So when we think about how do you validate a rapid test, we're going to look here at rapid lateral flow devices or the qualitative ELISA tests. There are two checks that need to be done. First of all, specificity. Does the rapid test detect the allergen in the specific sample matrix that contains it? That's a simple question to answer. And then the next check is, okay, and how sensitive is it? At what level does the test change from detected to not detected? The reason these two checks are so important is that we know rapid tests are well known for detecting, for example, the presence of milk protein in liquid milk, but maybe they're not very good at detecting milk protein in either cheese or yogurt. They are variable. We also know that they may detect milk protein in liquid milk at a very sensitive level, but may not detect milk protein in cheese at the same sensitive level. Now, in terms of understanding who should do these checks, it is very clear. It should be ideally the kit supplier who has made the rapid test. That is the best option because they are the experts in their testing kit that they are selling. They will also know what they have already validated, so it may be that they don't need to repeat the work. And of course, if their rapid test is shown to be good enough, then they're going to get sales out of this. So it is in their interest to help and assist us to do this validation. If they can't, then an approved testing lab that's on the approved testing list may well be able to help us do that. But ideally, choose the people who make the rapid test as your first port of call. Okay, I wanted to just run through a few of the questions that I get asked often. So I'm often asked is, are any rapid tests kits already validated? No, we don't have a list of what has or has not yet been validated. It is very specific site to site, it is very specific product to product, it is very specific rapid test to rapid test. So this is just a database that we do not have, we have not collated. It is up to the site to individually do that. However, if two sites are making exactly the same type of product and they're going to use exactly the same type of rapid test, that is to say that they could use the information validated by one site for another site. So it's important that you can share that. Okay, question 2. If I want to use a rapid test, where do I start? Well, first of all, you need to identify a supplier of the rapid test and contact them in order for them to do those checks that we've just mentioned. Number 3, do I need to record this validation, these checks? Yes, absolutely. You need to record what validation was underdone, who did it, what the results were, any rationales and choices that you made, and the decisions based upon those. And if the kit supplier has previously already validated a similar enough sample type, keep this information documented. We will need that information from the rapid kit supplier. Question 4. What happens if the validation fails? Well, the answer there is this demonstrates that the rapid test is not suitable or appropriate. So the next thing to do is, are there any other rapid tests that may be available for that allergen with a different rapid test supplier? Question 5. What is considered to be a failure? Well, if the rapid test does not detect the allergen in the sample type, that's a failure. Then we have a question over, well, how sensitive does it need to be? And this is a difficult question to answer because the question really is, if the rapid test does not detect the allergen to a similar sensitivity that the quantitative ELISA through the swabs that you'd be sending for quantitative ELISA testing on the cleaning validation, that would be considered a failure. So just as an example here, if the limit of detection of the rapid is approximately 100 parts per million and the sensitivity of the ELISA test is 1 part per million, that would be considered too different. In other words, you'd be using a rapid test that was not very sensitive to help you decide whether it was okay to continue with production, when actually that might be so much less sensitive than when you'd actually done the validation that that would not be a fair question to be asking. Question 6. What if I cannot find a suitable rapid test? Please remember that the use of rapid tests is only optional in cleaning validation. They do not have to be used, and in fact, they really should only be used if there is a good justification to use them. Question 7. What happens if I have any serious issues with either kit suppliers or selecting a test? You can answer, drop me a mail or an IM and I will try and help you based here at the Reading Science Centre in the UK. Okay, we're going to move on now to just think a little bit about indicative levels. We're all aware of what they are, and we now know that we have the new quality policy is very clear that if we can clean allergen off to a level where it is not detectable, then we should manage that change as a critical control point and minimise the need for cross-contact labelling. So if your indicative level study is on the left-hand side and the allergen cannot be detected and you've repeated the exercise 3 times, then it should be managed as a CCP and there should be no need to have a may contain warning. If we're in the middle bucket here, where you've detected allergen, but it is lower than the indicative level, then that's fine. It can be managed as an SPP and then revalidate if anything changes. If, however, you're on the right-hand side and you've done your testing after your indicative level study and actually the results have come back greater than the indicative level, then something has to change. The changeover needs to be optimized and those levels need to be reduced. If they can be optimized and the levels can be reduced to be less than the indicative level, then much as in the middle here, you're then going to manage it as an SPP and revalidate in the event of a change. When we think about what the indicative levels are, we have them here for some of the allergens that are important to Mondelez. It is really critical to understand that indicative levels are always as parts per million allergen protein. So when we look at peanut, the indicative level is 60 parts per million peanut protein. The reason that we are setting indicative levels when we have cross-contact labelling, so we have may contain peanut, for example, and we are trying now to limit how much peanut protein would be present with a may contain peanut warning, is because we know that some consumers who are allergic, they actively choose to ignore cross-contact labelling. So even though they are allergic to peanut, they see may contain peanut, 30% of them are still choosing to purchase and consume those products. So we are trying to restrict how much peanut protein would be present in those sample types so that they do not have serious reactions. When we think about actually testing for the presence of allergen in an indicative level study, there are some things that we need to think about, and it really is because the indicative level is all about the allergen protein. So let's take her through the flowchart that we have here. So the first step is clearly to identify the allergen that's going to be tested in the finished product. And I'm going to choose as an example here that the allergen is hazelnut and the finished product is plain chocolate. The next thing to do is to check what the indicative level is by referring to the QP. And for hazelnut, this is a tree nut, and we know that the indicative level is 100 parts per million of hazelnut protein. The next step is to find a Mondelez approved lab for the testing of that target allergen from the approved lab list. You can only use ELISA testing kits for a cross-contact level study because you need to be able to measure the protein. You'll then contact the approved lab, and you need to now know what the standard range of the kit is for the allergen of interest. So imagine we go through this exercise and the approved lab comes back and says, yes, we have hazelnut ELISA testing kit, and our standard range is 1 to 5 ppm of hazelnut protein. The next step here is to inform the lab about the range of interest that you're interested in terms of the results. And this needs to, of course, be based on the indicative level. So the standard range for this testing kit is 1 to 5 ppm of hazelnut protein. But of course, we're interested in the indicative level of 100 ppm of hazelnut protein. So we need to ask the lab to do some dilutions to extend their standard range. And ideally what we're wanting to have is that the indicative level, in this case 100, fits somewhere within about the middle of the detectable range. So for example, for hazelnut protein, if the range is 1 to 5, if the laboratory did a 10-fold dilution, then this changes the range from 1 to 5 to 10 to 50. But here we're interested in an indicative level of 100. So we're going to ask the laboratory to perform a dilution of a 40-fold dilution. And this will extend the standard range to 40 to 200. And we know that 100 is more or less in the middle then of this diluted range. This is a piece of work that we expect the laboratory to help us with. The lab will then perform the dilutions based upon the range of interest, and then we need to absolutely be sure that they are going to report the results in the total allergen protein. Okay, and then there will be actions based on, as we saw in the previous slide. So in these examples, we're likely to get 3 types of results coming back if they've done a 40-fold dilution for hazelnut protein. You may get a result reported as less than 40 ppm hazelnut protein. And what that's telling you is there's no hazelnut protein present above 40 ppm. You might get a number between 40 and 200, and then you'll have to decide whether it's above or below the 100 ppm of the indicative level. Or you might get a result reported as greater than 200, and that would clearly be above the indicative level. There is one watch out here, that if your result is reported at less than 40, of course there is a chance that actually there were no detectable hazelnut protein there at all. So here in this instances here, you really want to ask the lab to test the sample neat without doing any dilutions, so that their original standard range of 1 to 5 ppm of hazelnut protein is what you're interested in. in case the result comes back at less than 1 ppm hazelnut protein, in other words, non-detectable. And that may then mean that you can remove the cross-contact label for hazelnut. Just some examples here of the standard ranges and what they actually mean, but please be aware for each different ELISA testing kit, these ranges will be different. So this is just to illustrate the kind of thing that you might see, but the laboratory will be able to help you with this. Let's just finish up here with a little bit of thinking about some of the challenges with indicative level testing. So if the lab are not always clear that the units are in total allergen protein, you need to make it clear to the lab that they need to convert it into total allergen protein. This is their responsibility to do, not yours. If the result is reported as less than the indicative level but greater than the top standard in a NEAT test, a bit like we had the example before of reported as less than 40, what do I need to do? Well, you may need to ask the lab to do some more testing, either NEAT or at different dilutions, to actually understand how much allergen is actually present. When we think about how accurate is the testing, well, typical ELISA testing will have a plus or minus a measurement of uncertainty associated with it of between 15 and 30%. So in other words, if your result is coming back at 98 parts per million hazelnut protein, that doesn't necessarily mean it's definitely okay, and we would ask you then to contact your sanitation leads to help guide you through. We briefly mentioned that we have approved laboratories. So Mondelez approve external labs for allergen testing, and there's each approved lab must meet a defined set of criteria. So they must be independently accredited to the correct ISO standard, and only accredited tests must be used. Each approved lab must participate in proficiency testing for allergens and have their results available for review. And they must supply details on validation that they have done. And they must be open and available to do any of that spike recovery testing that we mentioned earlier. And the list of approved labs for which allergens in different regions is available through your sanitation contact. So, very last slide here to think about some frequently asked questions. So, if a result is reported as less than 2.5 milligrams per kilogram of milk protein, how much has been detected? Well, this is telling you that the lowest reporting limit of the test is 2.5 milligrams per kilogram of milk protein. So it's telling you that there is no milk detected above that level. It cannot tell you any more than that. If the result is reported as greater than 15 milligrams per kilogram of casein, how much is detected? Well, this is just saying that the upper limit of that standard range for that testing kit is 15, and there's been more detected than 15. So it might be 16, it might be 16,000, and this is where you might be able to ask for some dilutions to extend the standard range, as we talked about with the indicative level study. If I've done some quantitative swab testing, can I translate the result I have from a swab test into a part per million or a milligram per kilogram? And the answer is no. The result from a surface swab test is just a measure of how clean the surface is. You cannot do any kind of calculation to work out how much might transfer into the next product, which is why the next offline product is such an important element in cleaning validation. And then the last question. I did a test 2 years ago and the result was reported as less than 2.5 milligram per kilogram of almond. I have now used a different approved lab, and this year the result they have reported is 1.5 milligram per kilogram of almond. What do I do? Unfortunately, different labs may well use different testing kits with different limits. And this latest result of 1.5 milligrams per kilogram shows that almond has been detected. So if there have been no changes, it is possible that 2 years ago the level was not detected but may have been present. So you'll need to contact sanitation for advice. I'd like to thank you for that. We do have an open question and answer session just coming up, so any questions that you have, you'll be able to ask them in that session. Thank you. Bye-bye.